Hello everyone, welcome to Anand Faiz Academy. And today we're going to take a look at the lecture 2 of the binomial theorem where we will solve some exercise problems. So let's get started. The first problem states that the first three terms in ascending powers of x in the expansion of 3 plus px to the n are 243 plus 810x plus ux squared, where n, p, q are constants. We have to find the values of n, p, q. Okay, so how can we solve this? We can solve this by expanding 3 plus px to the n using our second generalized formula, which stated that a plus b to the n is simply given by a to the n plus n, a to the n minus 1, b plus n into n minus 1 divided by 2 factorial into a n minus 2, b to the 6, b to the 2, and so on and so forth. We will use that to expand. So first here a is 3 and our b is px. So we raise the 3 to the highest power, and then we decrement 1 by 1 in the following terms. And then in increasing power of x, we increment the power of px. So from 0 to 1 to 2. And once we solve this, we get this over here. Okay? Okay. Now using these terms, we will compare the coefficients and find the value of each term. So the first term is 243. So 3 to the n is simply 243. Then how can we solve for n? We can take the natural log on both sides. Then we can bring down the power n and then divide by 3n, natural log of 3n on both sides to get 5. Next, we have n times p times 3 to the n minus 1, which is this term, this coefficient. So that is compared with 810 over here as given. So n is 5 and p is unknown, and 3 to the n minus 1 is just 3 to the 4, and all of that will equal 810. If we solve for p is found to be 2. Finally, how can we find q? Q can be simply given by this coefficient over here, right over here. So this entire coefficient is equal to q. We know the value of n and p, and we also know the value of 3 to the n minus 2. So we simply plug those values in, and q is found to be 1080. Let's take a look at part B. Find the term independent of y in the expansion of 2y minus 1 over 3y squared whole to the 6. Give your answer in exact form. How can we solve this? So we can use the general term of the binomial expansion of, let's say, a plus b to the n can be simply given by the general term tr plus 1 is given by ncr, a to the n minus r, b to the r. So here, a is 2y and b is minus 1 over 3y squared. If we bring the y to the top, the positive power in the denominator will become negative power in the numerator. Okay? Then what we will do is we will bring out the y from this bracket over here. From this bracket over here, we will bring out the y, and then that the y will be raised to the r. Okay, that's perfect. And then what we can do, we can bring out the y over here, 2y outside, and that will divide the power between y and 2. Then we will accumulate the y. In this case, they're being multiplied, so the powers will be added. So 6 minus r added with minus 2r will give you 6 minus 3r. So a general term is this. So for the term to be independent of y, this entire part over here has to equal 0, because anything to the power 0 is 1, except 0, of course. That is undefined. So once we equate that to 0, excuse me, sorry for that. So once we equate that to 0, we get r equals 2. Now, if you plug in 2 in our general formula, we will get the term which is independent of y, and that is 80 by 3. Done. Okay, now for number 2. Find the first three terms in the expansion of 1 plus x over 7 whole to the 5 in ascending powers of x, simplifying the coefficient of each term. Okay, so this is a really easy question. We just need to follow the a plus b to the n. We just need to follow a to the n plus n nc1 a to the n minus 1 b plus nc2 a to the n minus 2 b squared, and so on and so forth. So the first term is just 1 to the 5, which is 1, plus 5c1. 5c1 is equal to 5, so that's here over here. And then we have to raise x by 7 to the first power as it's increasing, as it is in ascending powers. They wanted it ascending powers of x. And then the third term is 10, which is 5c2, that's 10. And then x over 7 whole squared. And simplifying this term, we get 1 plus 5 over 7x plus 10 over 49 x squared, and so on and so forth. These are the first three terms that they wanted. Okay, the expansion of 7 plus 1 x to the n plus 1 plus x by 7 whole to the 5, where n is a positive integer, is written in ascending powers of x. The first two terms in the expansion are 7 plus 89 x. Find the value of n. Okay, how can we solve this? We can simply solve this by expanding 1 plus x to the n using this a plus b to the n equals a to the n plus n a to the n minus 1 b plus n into n minus 1 over 2 factorial a to the n minus 2 b squared, and so on and so forth. We can use this to expand 1 plus 7, 1 plus x to the n. And once we do that, we will get this over here. We don't need the x squared because they only gave us the first two terms, so we can only use, the first two terms of this entire expansion. Okay, distributing the 7, we get 7 plus 7 nx, and the first two terms of our previous previous expansion that we did, we can simply input that here. So we get 1 plus 5 over 7x. Then let's distribute the 7s. So we get 7 plus 5x plus 7 nx. And we're not taking 7nx into 5 over 7x because that would give you a squared term. And since squared term is not given, we don't need to expand further. Okay, so we have 7 plus 5x plus 7nx. We have 5 plus 7nx as we take the x common or factor out the x. Now we can just simply compare the coefficient. So the first term is 7, and that matches. So first term is 7. Our expanded term is also 7. So that matches. The thing that's unknown is this part over here. So this part has to be equal to 89. So 5 plus 7n equals to 89. So 7n has to equal 84, and n is equal to 12. Perfect. All right, number 2b. In the expansion of k minus twice x to the 8, where k is a constant, the coefficient of x to the 4 divided by the coefficient of x squared is 5 over 8. The coefficient of x is positive. Form an equation and hence find the value of k. Okay, how can you solve this? So the way to solve this is to first write down the general term of our expansion. So it's simply NCR into a to the n minus r, so which is 8 minus r, times b to the r, so that's minus twice x to the r. If we take the x out of the equation, out of the bracket, sorry, we get x to the r. And this is our general form. Okay. Okay. So when r equals 4, our term number becomes 5, and our general term becomes 1120. And when r equals 2, our general term becomes a third term, and our general term becomes 112 k to the 6th power x squared. 1120 k to the power 4 times x to the 4, and 112 k to the power 6 x squared. So the thing that's given is that the coefficient of t to the of the 5th term, or x to the 4th term, divided by x squared, the coefficient of the third term, is simply given by 5 over 8. So 1120 k to the power 4 divided by 112 k to the power 6 is equal to 5 over 8. All right. Uh, yes. Okay. So, okay. Then we solve this equation with where k is the unknown to get k equals plus minus 4. Now, will we take the minus 4 or the plus 4? Here it says that the coefficient of x to the where is it? The coefficient of x is positive, okay? So it has to be a positive, uh, positive. The coefficient of x has to be positive. So here, the x coefficient, we need to find the second term where the x term is there, okay? So here, once we solve it, once we find the general term for x, we see that it's minus 16 times k to the 7 into x, okay? So this entire thing has to equal a positive number. So k has to be negative in order to cancel out the negative part of the 16 in order for the coefficient of x to be positive. Since k is raised to the odd power. So anything to the odd power gives you negative, and negative times negative gives you positive. So we have to use minus 4. If we had used plus 4, then the coefficient of x would not be positive. It would be negative. So we would take k equals minus 4 here. Okay. A lot of people make this mistake since the question says it's positive, they take the positive value of k, but the coefficient of x is positive, not the value of k is positive. The value of k needs to be negative in order for it to be multiplied with another negative number, so the whole thing becomes positive. Okay. Number 3. In the expansion of ax plus b over x squared whole to the 9, where a and b are constants with a greater than 0, the term independent of x is minus 145,152, and the coefficient of x to the 6 is minus 6,912. Show that a squared b is minus 12 and find the value of a and the value of b. Okay. All right, so how can we solve this? Easy way to solve this is to first write down the general term of our binomial expansion, okay? So the general term of our binomial expansion is NCR into a to the n minus r, a to the n minus r times b to the r, or here b, the whole b is just bx to the minus 2. I'm writing b over x squared as b times x to the minus 2 because if we bring x squared to the numerator, the power becomes negative. Okay. So here we write the constants separately and write the x values separately as well. And once we add these two x's, we get x to the 9 minus 3r. So for independent term of x, this entire thing has to equal 0, right? Okay. And then that will give us r equal to 3. That's perfect. All right. So the next thing that's given is that the term independent of x is minus 145,152. So what we do is that the fourth term is the independent term. So we simply give r equals that into the general term equation, and then we get the fourth term, and that's found to be 84 a to the 6 b to the third. Okay, so 84 a to the 6 b to the third is minus 145,152, and a to the 6 b to the cube is equals to minus 1728. And if we take the cube root on both sides, we get a squared b equals to minus 12. And that's what they wanted us to show. Okay, now how can we find the value of a and b? For that, we need to find our x to the sixth term. So for x to be raised to the sixth power, we need this entire thing to be equal to 6. So 9 minus 3 has to equal 6, and then r would be equal to 1. So it's the second term that has the x to the sixth term, or x to the sixth power. So if we simplify this, we simply get 9a to the 8 bx to the 6. All right. So the given thing is that this entire term, or the coefficient of this term, is equal to minus 6912. So if we equate this together, we get a to the 8 times b equals minus 768. Okay, so this is our equation 1. And this is our equation 2. So then what we will do is we will form an equation 3 using equation 1. So we will just subject b. So b would be equal to minus 12 over a squared. Okay, so then we will substitute. What we will do is we will substitute the equation 3 into equation 2. So what will happen then? So b is simply given by minus 12 over a squared. So we will just simply input this in this equation. And then that multiplied with 8 would become a to the 6th equal to 64. Therefore, a has to equal plus minus 2. But in the question, it says that a is greater than 0. So a must equal positive 2. So since it's positive, then how will we find b? We will just simply use equation 3 and then substitute that value of a. So it will be minus 12 over 2 squared, and b would simply be equal to minus 3. And that's problem number 3. All right, problem number 4. It is given that the first 4 terms in ascending powers of x in the expansion of 1 minus x over 2 to the n can be written in the form 1 minus 8x plus px squared plus qx to the cube, where n, p, q are integers. Find the values of n, p, q. Here we will simply use the form a plus b to the n equals a to the n plus n a to the n minus 1 b to the 1 plus n into n minus 1 over 2 factorial a to the n minus 2 b to the second power plus so on and so forth. We will just use form or this formula to calculate the values of NPQ. All right. Okay. So once we simplify or once we expand this over here, we will get 1 plus n times minus x over 2 plus n into n minus 1 over 2 factorial into minus x over 2 whole squared plus n into n minus 1 into n minus 2 over 3 factorial multiplied with x minus 2, x divided by 2 minus x divided by 2 whole to the cube. And once we simplify this, we will get 1 minus n over 2x plus n into n minus 1 over 8x squared minus n into n minus 1 into n minus 2 over 48x cubed. And if we simply compare the coefficients, we can find the value of n, which is found to be 16. We can find the value of p if we simply input the value of n in our second coefficient, or sorry, the third coefficient, and that's found to be 30. And then we can find the value of q, which is our fourth coefficient. If we input all the values of n over here, we get q is equal to be 70. And that's it. All right, number 4, b. Find the term independent of x in the expansion of 2 over x squared plus x over 3 whole to the 6, giving your answer as a rational number. Okay, rational number is in the form of a over b or p over q. So that's a rational number. All right. So first what we'll do is we will write the general term of our expansion. So if we bring the x squared to the top, it will become x to the minus 2. And that's being raised to the n minus r, or 6 minus r. And then that's being multiplied with x over 3 to the r. Bringing out the 2, and 1 over 3 as a separate form itself. We get 2 to the 6 minus r and multiplied by 1 over 3 to the r. And we accumulate the x's together and then added together, it becomes 12 minus 12 plus 3r. So for the term to be independent of x, this entire thing over here has to equal 0, right? So 12 minus 12 plus 3r has to equal 0. And if we equate that, we find r to be equal to 4. That's perfect. So it's the fifth term in our expansion that is independent of x. So if we input r equals 4 in our equation, we get the value of the fifth term, and that's found to be 20 over 7. And that's it. Thank you for watching, guys. Please stay tuned for more videos. This is Anand Faiz Academy signing off.